Today we're going to be looking at average value and how that relates to integration. So if we have a graph of a function, okay, and let's say this is our function here. We could draw our left Riemann sum or our right Riemann sum, or we could draw the height of the rectangle really anywhere at any function value in between the left and the right. So in this case, if we drew it right here at the very top, that would most definitely be an overestimate. So it would be the highest value the function has. We could also draw it at the bottom, say about down here somewhere, well down in about here, would be the lowest it occurs. But there's somewhere in between that's got to be just right. And what I mean by just right is I mean the area, so this area right here, this kind of shaded area here, this kind of yellow shaded area, is the same as the green striped area. If you found that just right place, it's sort of like Goldilocks and the Three Bears. Too small, too big, just right. So the one that's just right here is going to be, we could interpret this as the height being the average height on this interval. So if this was the average height, this area is the same as the actual integral. Okay, well, what's the area of this thing? Well, it's the average height times the width of the interval, which was b minus a. And so, on the one hand, this area is the average height times b minus a. And on the other hand, it is equal to the integral. Okay? Well, if you just solve for the average height, you're dividing both sides by this constant b minus a, and so the average height, we'll call f average, is 1 over b minus a times the integral from a to b of f of x dx. Hopefully that kind of makes sense. So we will basically use that as a definition of the average height of a function. Now, it's a pretty straightforward, easy idea, but there's something remarkable about this as well, because think about what we're doing. We know how to average the height if it's of a discrete case. We just add up the number of items we have and divide by how many we have. But what this is an average height. So you can kind of think of it the same way. This integral is summing up all of the stuff here, and then we're dividing by not how many we have, but we're dividing by the width of the interval. So it's kind of the same thing, but a little different. So we're actually finding an average of an infinite number of things. These infinitely many y values that we have going along the curve, we're averaging those infinitely many things and coming up with an actual number. That's kind of a remarkable thing that we're able to do here. Okay, so that is the average value. In our next video, we're going to see how the average value concept helps lead us to approximating a definite integral from a graph pretty effectively.